Tonight we will be working with subtracting signed rational numbers. We're going to focus on fractions and mixed numbers. So our objective is I can subtract signed fractions and mixed numbers using number lines and the rules for addition of integers. You remember when we subtracted integers, we simply rewrote our subtraction statement as an addition statement and then fell back on our addition rules for integers. We're going to do that same process, but now with signed fractions and mixed numbers. Find the following difference using a number line model. So there's our number line. Minus 3/2 means from 0. We will go 3/2 to the left. And then if we're subtracting a positive means we will move left some more. We remember that from our video on subtracting positives on the number line. If you don't remember, please review that video. So we need to just move left another 1/2. Where are we at? We're at -4/2 or -2. So that's -4/2, which is -2. Let's look at the same example, but without using a number line. Just like when we were subtracting integers using our rules, your first step is to rewrite the subtraction statement as an addition statement. And we remember to do that, you change your subtraction to addition. You take the opposite of the number being subtracted. You change the sign of the number being subtracted. As soon as you're done rewriting that subtraction statement as an addition statement, fall back on your rules for addition, which means you'll circle the sign that goes with the number. That first number has a negative sign right in front of it. Our second number has a negative sign right in front of it. Are the signs the same or the signs different? Those signs are the same. They both have a negative in front, so we'll find the sum. So I'm going to find the sum of 3/2 plus 1/2. Sorry about that. 3/2 and 1/2. Sum means to add, and this is alliteration, right? Signs are the same, find the sum. 3 plus 1 is 4/2, which is just 2. Since we had a common denominator, we just had to add the numerators and keep the denominator. Then you're going to ask yourself, what do you have more of? Well, here I have 3 negative halves. Here I have another 1 negative half. Oh, what do I have? I have 4 negative halves. I only had negatives, therefore my answer would be negative. And -4/2 is the same as -2. Sorry about that. -4/2 is the same as a -2. 4 divided by 2 is 2. Find the following difference using a number line model. Okay, so it's -1 1/3. Again, as you see this number line, I've broken it up into thirds because I know that my fractional part is dealing with thirds, so it's most appropriate to break my number line up into thirds. So I go from 0 to -1 1/3. There's -1, there's -1 1/3. And then I'm subtracting a negative. Remember, on a number line, when you subtract a negative, to subtract a positive, we moved left. So to subtract a negative, we will need to move right on the number line. Again, feel free to go back and review the video on subtracting negative integers on the number line. But subtracting a negative, we'll have to move to the right. So I'm going to move to the right 2 2/3. -1/3. I'm going to jump -1 1/3. If I jump 1, we're at negative, so I'm jumping 1. I end up at -1/3. If I jump another 1, jump another 3 parts. There, I've jumped another one. I end up at 2/3, and then I just need to add on another 2/3. So 1 2/3 ends me at 1 1/3. And I have to tell you, I almost feel like working out the mixed numbers on the number line can be tricky for some people. So you might want to always fall back on your rules for adding and subtracting sign numbers. But you know what? If you're comfortable with number lines, you work it out on the number line. Rewrite the following subtraction statement as an addition statement, then use the rules for adding sign numbers. So we're going to take the same problem. I'm going to take that subtraction statement, rewrite it as an addition statement. Minus a negative becomes plus a positive. Then I fall back on my rules for addition of sign numbers. Circle the sign that goes with the number. That first number has a negative in front. Once I rewrote as the addition statement, that second number has a positive in front. So are those signs the same or are those signs different? Those signs are different, so we'll find the difference. So I'm going to take 2 2/3 minus 1 1/3. 2 minus 1 is 1, so that's 1/3. And then here 2 minus 1 is 1, so that's 1 1/3. That's my scrap work off to the side. Since we had the common denominator, we simply subtracted the numerators, kept the denominator, then we subtracted the whole number part of the mixed number. That's how we work that out. Then you have to ask yourself, what do you have more of? Well, I have a negative 1 1/3. I have a positive 2 2/3. I definitely have, I definitely have more positives, so my answer is positive. Well, we're going to need to fix this up. We have more positives. Once we rewrote as an addition statement, we definitely have more positives. Therefore, our answer will be a positive 1 1/3. Sorry about that. There's a misprint on the slide. Let's go to the next one. Let's find the following difference using a number line. Okay, so again, I move over to 1 1/2. When we subtract a positive on the number line, we know we'll need to move left to subtract a positive. So we'll move left 2 1/2. So I'm going to first move left 1/2, and then I'm going to jump 1 2. So if I move 2 to the left, 2 1/2 to the left from 1 1/2, I end up at a negative 1. So that answer we know using a number line is a negative 1. Now let's use our rules. First thing we're going to want to do is rewrite that subtraction problem as an addition problem. Then we'll use our rules for adding integers. So we're going to rewrite this subtraction problem as an addition problem. So we'll change our subtraction to addition, and we'll change the sign of the number being subtracted. Then we'll circle the sign that goes with the number. In front of our front number, we don't see a sign, so we're like, oh, okay, that must be a positive number. Our second number is negative. Signs are the same or the signs different? The signs are different, we'll find the difference. So then off to the side, I'm just going to go ahead and find the difference. 2 1/2 minus 1 1/2. And you'll notice I'm ignoring the signs at this point. I'm just following. If the signs are different, find the difference. 1/2 minus 1/2, bye-bye. 2 minus 1 is 1. Then at that point, I say to myself, okay, so I know my final answer is going to involve a 1. Are there more positives or more negatives? There's definitely more negatives. There's 1 1/2 positives. There's 2 1/2 negatives. There's definitely more negatives, so my final answer is negative. You'll notice this is just my scratch work off to the side. What if we subtract rational numbers without a common denominator? First, we must rewrite our subtraction statement as an additional statement, always. So I changed my subtraction to addition, and I changed the sign of the number that was being subtracted. We were subtracting a positive 9/5, so I changed that to a negative 9/5. The signs are the same, so I find the sum, right? We circle the sign that goes with the number. The signs are the same, so I go ahead and I find the sum. But the problem is this time there is not a common denominator. We rewrote our subtraction statement as an addition statement. We realized that we need to find the sum because those signs are the same, but there's not a common denominator. So I'm going to just find my sum off to the side. I'm going to rewrite each of these as an equivalent fraction with a denominator of 20. 4 times 5 is 20. Whatever we do to the denominator, we must also do to the numerator. 3 times 5 is 15. 5 times 4 is 20. 9 times 4 is 36. We're going to add those up. 15 and 36 is 51 over 20. How many times is 20 going to 51? Twice, with 11 left over. So it's 2 and 11 20ths. So we have our common denominator. We added the numerators. We kept the denominator. We rewrote our improper fraction as a mixed number. So this is 2 and 11 20ths. The only thing to decide is my final answer going to be positive or negative. So I say, what do I have more of? Hey, all I have is negatives running around. Here I have 3/4 of a negative running around. Here I have 9/5 of a negative running around. I only have negatives running around, which means my final answer will be negative. Once you ask, do I have more negatives or more positive? For positives, there's only negatives. Final answer will be negative. If you need to pause the video and go back, I know I went through the addition of the fractions very quickly, but hopefully you noticed that this video is very similar to an earlier video we watched this year. What I'd like you to do is I'd like you to subtract the following signed rational numbers and be ready to share your results in class tomorrow. Thanks. Have a good night.